So with this experiment, we're gonna be mixing salt and pepper together on a plate. Take a balloon, fill it with air, and rub it against my head, holding the balloon over the salt and pepper and seeing what happens. And so the materials. And so the materials that I'm going to use is step 1, blowing up a fresh balloon and tying it close and setting it aside for a moment. And then the next thing I'm going to do is get salt and pepper, in which I have in here, and pour it onto a plate. And by using 2 fingers, I'm going to be mixing the salt together, as you can see. And as I'm doing that, I'm aggressively gonna rub the balloon against my head. And as I rub the balloon against my head, we're gonna see what happens. So as you can see, some of the particles are already sticking to the balloon, as already demonstrated. And so my hypothesis was a mixture of salt and pepper can be separated by making a use of physical properties such as weight, color, and electrical charge, because these different properties, because that salt and pepper act different. Because as you see, salt is small and rough and a crystalline acid, and pepper is the same thing, as well as being small, black, brown, and a light solid. And so with some of my observations, was what happens to the pepper and flakes. My second observation was what happens to the salt flakes. The third option was that the balloon capture both protons and electrons, and what happens to the static of electricity. For, which you guys don't all know, the process of static electricity is the buildup of electrical charges on the surface of an object within occurs when electrons are pulled above the surface from one material, relocated to the surface of another material, which I did with the salt and pepper gathered to a balloon by rubbing my head conducts static electricity. And so with my results, by proving, as you can see, the experiment was a success, proving that both salt and pepper have physical properties that interact from the static electricity from the balloon. By rubbing the balloon against my head creates a friction force and of static electricity. The charge pushes the electrons toward the back of each pepper particle and then attracts from side to side, which now has a positive charge. But with the addition of, as you can see, my wild hair, it attracts the balloon's electrons that have a negative electrical charge, because the protons in the salt and pepper are both positive charges, and because opposites attract, you'll see salt and pepper levitating up from the plate and sticking to the balloon, as demonstrated right here. And so from the experiment, by rubbing the balloon against my hair, causing the balloon to collect electrons, the balloon comes negatively charged. But after charging the balloon, the closer you get to the salt, as demonstrated, the pepper and mixture are slowly brings up closer. The positively charged pepper jumps up quickly and sticks to the balloon. As you can tell, there are more black particles that are demonstrated as pepper compared to salt, because the positively charged pepper jumps up quickly and sticks to the balloon, leaving the salt behind. The salt remains on the table because it is heavier than the pepper. The pepper is easily lifted by the balloon, causing static electricity, because it is a low density, giving him more surface area of a given amount of space. But as you can see, the salt remains harder for the salt crystals that have a higher density that cannot be easily lifted, causing no difference in static electricity. As you can see, this experiment was a success by following the different procedures and different options conducted with this experiment. Thank you.